In this video, we're going to go over graphing rational expressions and all of the key elements that are involved in doing that. So I want to go over this first. So you may get an equation, f of x or y equals the numerator over the denominator. This is our process, guys, all of these steps. And so I wrote them out so you guys would understand them. I'm going to explain them as we go. So with a horizontal asymptote, if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. If the degree of the numerator is equal to the degree of the denominator, then we take the coefficients of those x's to the second, we'll say it is, whatever they are. So if the x to the second on top was 1 and the x to the second on the bottom was 2, then it would be 1/2 equals y. Now, if the degree of the numerator is less than the degree of the denominator, then y is equal to 0. Now, the next step is going to be to factor the numerator and the denominator and then cancel any repeated factors. At this point, whatever is in the numerator, we're going to set that equal to 0 and solve it. That's our 0. When we're trying to find our whole, we're going to set our repeated factor equal to 0. We're going to solve for the x, and then we're going to put that x back in our simplified equation from above, and we're going to solve for y. That's going to give us an ordered pair for our whole. Our vertical asymptote, we're going to set the factors of our denominator equal to 0. Again, our factors after we have simplified it. And then we're going to solve for that, and we're going to say x equals. And by the way, our horizontal asymptote up here will always be y equals. Now, when we're talking about our domain, which is our x values, it's all real numbers except the x value of the whole in the vertical asymptote. The range, which is y values, are all real numbers except for y value of the whole in the horizontal asymptote. Now we're talking about intervals of increase and decrease. Usually we're only going to have one of these, okay? So we're going to look at the graph and determine what is happening as you move from left to right. And if the graph's going up, then it's increasing. And if it's going down, then it's decreasing, okay? Then use the values in the domain to determine how it moves from negative infinity to positive infinity, remembering that the x value of the whole in the vertical asymptote will be in your intervals because the graph pauses at both of those values, right? Now, when we talk about end behavior, we're going to look at the graph again, and we're going to look at what happens to the y values as you move from positive infinity towards negative infinity. And towards negative infinity with your x values. So basically you're looking at your x as you're moving towards positive infinity. Where's the graph headed? Is it headed up, which would be positive infinity, or is it headed down, which would be negative infinity? Same way when we're looking at our x values, when we move in towards negative infinity, is the graph headed up, positive infinity, or is it headed down? That would be negative infinity. Then what you need to remember is that if you have a horizontal asymptote, y'all, that is always going to be your end behavior. So if you had your horizontal asymptote is y equals 2, then your end behavior is going to be 2. All right, so for this given graph, we're going to look at this and we're going to answer these questions, okay? So it's asking for I'm going to go ahead and work through each of these one at a time, and I'm going to do it in the order, and then I'm going to go back and talk about domain and range, okay? So our zeros. So this right here is one of our zeros, so that's at -5, so x equals -5. And this right here is one of our zeros, so x equals 3. Then we're talking about holes. I don't see any holes. That would be a hollow dot on the graph, so there's none. Vertical asymptote, that is this dashed line right here, y'all. This is our vertical asymptote right here. Y'all see it? If it's a dashed line, it's an asymptote, okay? So this is going to be x equals 2. I don't see a horizontal asymptote. I don't see a dashed line that goes horizontal, so I'm going to write none here. Now I'm going to go back and talk about domain, increasing and decreasing in end behavior. So our domain. So let's look at our x values. So as we're moving across here from left to right, so we're going to say all real numbers except what, y'all? Now on the previous slide, I told y'all it would be except the vertical asymptote and the whole. We don't have a whole, but we do have a vertical asymptote, so it's going to be everything except for 2, right? Now when we're talking about our range, we're going to talk about our whole and our horizontal asymptote. Well, we don't have either one of those, so this is going to be all real numbers, okay? Now, when we're talking about increasing, so as we're moving from negative infinity here to positive infinity, right? What's happening to the graph? So is the graph increasing? Is it going up or down, guys? Hopefully you can see that the graph's going up here, right? And it's going up here, right? So this is going to be an increasing, which means there's not going to be any decreasing. All right, so now we want to see what are the intervals of increase, okay? So we're going to talk about going from negative infinity to, where's our hole? Again, we're going to talk about holes or vertical asymptotes. Didn't have a hole, right? So this is going to go from negative infinity to 2. And then we're going to pick it right back up at 2, and we're going to take it on to infinity. Okay, that's the only time our graph pauses. And remember, these have to do with our x's, right? Then we're talking about end behaviors. We're talking about as x approaches positive infinity. So here, as we're going this direction on the graph, y'all, what's happening to y? Isn't it going up? So this is going to be positive infinity. And over here, as we head this direction, what's happening to the graph? Isn't it going down, y'all? See that? So this is going to be negative infinity. All right, so on this next one, we need to factor it first. So let's go ahead and do that. Well, actually, let's do our horizontal asymptote first. So y'all see this right here? We're going to compare these first for our horizontal asymptote. And there's a 1 in front of there. So this is going to be y equals 1/2, right? I'm going to go ahead and draw that to the best of my ability. We'll see how well I can do that. 1/2. Y'all get my drift here. I'm trying to do the best I can, okay? So that's our horizontal asymptote. Now we're going to factor this thing, okay? So we're going to say y equals, I'm going to factor the numerator and the denominator. And I'm going to factor a 2 out of this, y'all. So that's going to give me x squared minus 3x minus 10. There was a GCF, right? So I'm going to do 2 out here. And then I'm going to factor it. So what are the factors of negative 14 that when added together give me a negative 5? That would be x minus 7, x plus 2, right? What are the factors of negative 10 that when added together give me a negative 3? That would be x minus 5 and x plus 2. Okay, so you should see right now that we have a repeated factor, right? That's going to affect our whole, okay? So now our equation is going to be y equals x minus 7 over 2 times x minus 5, okay? So that's going to actually be our equation that we're going to use now to find our other things. So 0. So we're going to set our x minus 7 equal to 0. X minus 7 equals 0. So x equals 7. So that's our 0. We're going to go ahead and plot that. Okay, then we're going to talk about our whole. So our whole is our repeated factor. Y'all see the repeated factor right here? So we're going to do that. Now we're going to do x plus 2 equals 0. So x equals negative 2. And then we're going to take that negative 2, we're going to put it back in the equation that we have right here. Okay. So we're going to say y equals negative 2 minus 7 over 2 times negative 2 minus 5. That's going to be negative 9 over 2 times negative 7, which is negative 14. So this is actually going to be 9/14. So when we're talking about our whole, it's going to be at negative 2, 9 over 14, which is a little more than 1/2, right? Okay, so let's go ahead and make that whole. So our whole is at negative 2, 9, 14. So it's going to be above this dashed line, but it's going to be barely above it, y'all. Got it? So it's like about there, okay? Now, our vertical asymptote, what do we do for it? We set the factors of our numerator equal to 0, right? So that's what I'm going to do next. So I'm going to say x minus 5 equals 0, so x equals 5, right? So this is x equals 5. So I'm going to go ahead and draw that now. That's my vertical asymptote. Okay. So now when we're talking about domain and range, domain's going to be all real numbers. except what? Our holes in our vertical asymptote. So it's going to be except the x value of the hole. So we're going to say except -2 and what? What's the vertical asymptote? Is it 5, right? Okay. Then for our range, we're going to say all real numbers again, except our y value of our hole and our horizontal asymptote. So now, I'm going to go ahead and graph this now. So I'm going to go to Desmos, look at the graph, and use it to graph this equation, okay? Oh, by the way, there's one other point that I could plot, y'all. I could put 0 up in here, and that would give me -7 over -10, which is 0.7, right? So that's right there. So I could actually plot that point too. That's my y-intercept. So now I'm going to go ahead and graph this. Let's do it in red. Okay, so I'm coming along here by my asymptote, going through that point right there that I graphed, and then up, right? Again, not looking for perfection here. Coming along this asymptote, going through that point right there, right? And then out. So remember that this is a hollow point right here, right? So I'm going to actually do it in a different color on the outside because it's hollow. Okay? Because that's where our hole is. Okay, so now let's talk about this. Can you see where the graph, is the graph increasing from left to right? So as I'm moving along this graph right here, y'all, is it going up or down? Even here, it's going up, right, y'all? So that's going to be increasing. So that means there's no decreasing. Okay? So now when we talk about our intervals of increase, we're going to talk about holes, the x value is holes, and the x value of our vertical asymptote. So we're going to go from -infinity to our first hole, which was at -2. Then we're going to pick it up from there and go from -2 to our vertical asymptote, which was at 5. And then we're going to go from there on to infinity. Okay? Now, when we're talking about end behavior, we want to talk about what's going on at the end of this graph. So as I head towards positive infinity here, y'all, what's happening to the graph? Isn't it headed towards our horizontal asymptote, which is 1/2? And over here, same thing. As I head towards negative infinity, where's our graph headed? It's headed towards that horizontal asymptote again. Remember, horizontal asymptote is always going to be our answer for our end behavior if we have one. Okay, so here's our next one. So we're going to factor this again. What are the factors of -6 that when added together give you a +1? -2 plus 3, so that's going to be over x plus 3. So these two are going to cancel out, right? So it's going to be y equals x minus 2, which I know is a line. So here we go again. So let's look at our horizontal asymptote stuff right here, okay? And so if the numerator is greater than the denominator, then there is no horizontal asymptote. And zeros, we're going to set x minus 2 equal to 0, so x equals 2, right? Our holes are our repeated factors, so we're going to say x plus 3 equals 0, so x equals -3. We're going to put that -3 back in that equation. Y equals -3 minus 2, so y equals -5. So our hole is going to be at -3, -5. Then we didn't have a denominator, did we? So again, we're not going to have a vertical asymptote either. So now let's talk about our domain and range, okay? So our domain is going to be all real numbers except what, y'all? Do we have a hole or a vertical asymptote? Yes, we have a hole. So we're going to say except -3. In range, same thing. We're going to look at our hole in our horizontal asymptote. So here it's going to be except -5. So that's where we're going to put our hole actually. So let's go ahead and plot some of this stuff now. Let's go ahead and plot our 0. That's right here. Let's go ahead and plot our whole at -3, -5, which would be like right here. And there's one other value, y'all. I could, up here in this equation, I could say y equals 0 minus 2, so y equals -2, right? So that's going to be right there. That's our y-intercept. Now I can just go ahead and draw my graph through those points, right? So that's what I'm going to do to the best of my ability. Okay, so let's talk about increasing, decreasing. Is this graph going up or down, moving from left to right? Up, right? So the decreasing is going to be none again. And it's going to increase from -infinity to our whole, which is at -3, and then it's going to pick back up at -3 and go on to positive infinity, right? Or infinity. All right, and behavior here. So as I'm approaching positive infinity here, what's happening to my y value? Isn't it approaching positive infinity up here, y'all? So that's going to be positive infinity. And then same thing as I go towards -infinity here with my x value. So as x approaches -infinity, what's happening to f of x or y? It's going towards -infinity, isn't it? So we're going to put -infinity here. All right, number 4. So let's look again here. So for our horizontal asymptote. So there's our horizontal asymptote. So if our degree of our numerator is greater than our degree of our denominator, then this is going to be none, right? Now let's go ahead and factor. What are the factors of -24 that when added together give you a positive 8? So I would say, or positive, yeah, positive 5 plus 8 and -3, right? Now notice this time we don't have any repeated factors, y'all. So if we don't have any repeated factors, then we can say that there are no wholes, right? Okay, so this time we're going to set our two factors in our numerator equal to 0. So we're going to do x plus 8 equals 0. So x equals -8. We're going to do x minus 3 equals 0. So x equals 3. So our zeros are x equals -8 and x equals 3. I'm going to go ahead and plot those. -8 and positive 3. Vertical asymptote is going to be our denominator, right? So we're going to go ahead and go x minus 2 equals 0. So x equals 2. So x equals 2 is our vertical asymptote. I'm going to go ahead and plot that. And then we're going to talk about our domain. So remember, domain has to do with, so we're going to say all real numbers except what, y'all? Our whole and our vertical asymptote. So what is our whole? We don't have one, right? But we do have a vertical asymptote, so we're going to say except 2. And then with our range, it's going to be all real numbers except what? Our whole and our asymptote. So there was no whole, nor was there an asymptote. So this is just going to be all real numbers. So now I'm going to go ahead and graph this. And again, I could put 0 up here, y'all, to find the y-intercept, which would be, let's go ahead and put 0 up here. So that would be 8 times -3, which would be -24. And that puts 0 there. That would be over -2. So that would be 12, right? So it would be way up here, y'all. That would be our y-intercept. Okay? So as we graph this, let's see, let's just graph it. I'm going to go ahead and graph it in green, y'all. So it's going, I think I saw a point like that, and it's going up way up here. Y'all got that? That's the graph there. And over here, it's going to approach again, and it's going to go through that point, y'all, and then it's going to go up here. And again, you can plot some other points. You can look at your x and y values in your table function if you want to get some more accurate points, okay? So look at this graph again. Is it increasing or decreasing, moving from left to right? Yes, it's increasing. So again, the decreasing is going to be none. And where's it increasing from? So we're going from -infinity to our whole, right, y'all? Nope, we don't have a hole. So what else do we have? We have a vertical asymptote. So we're going to go to 2. Okay. Then we're going to pick it back up at 2 and go on to infinity. So remember, these are our x values, guys, and we're looking at holes in vertical asymptotes when we're talking about increasing and decreasing. So it really has to do with our domain. You can always use your domain and your exceptions of your domain to write your increasing, decreasing statement, okay? So now as I'm headed towards positive infinity, where's the graph headed, y'all? Yep, positive infinity. And as I'm headed towards negative infinity here, yeah, where's our y value headed? Isn't it headed down, y'all? So this is going to be negative infinity.